Hi there, how are you doing today? Namaste, good morning, afternoon, wherever you are. My name is Vishnudat and I work as a network architect in Cisco. We are going to discuss our question number 4 of this series, which is how to avoid loops in layer 2 network, right? So if you can see here, uh, we are going to change our presentation style from this video, right? Nothing major change, but yes, I found it a little bit more interactive while I work on whiteboard. So in my previous videos, you must have noticed that the presentation style is slightly different than the presentation style of this video. So be with me, guys. The quality is going to be the same, and we will be discussing the remaining question in this format. Okay. Having said that, let's talk about how to avoid loops in layer 2 network. But wait a minute. What is the intent of this question? The intent of this question is whether you have worked within an enterprise or not, right? Whether you have worked in layer 2 environment of an enterprise or not. If you have, then you must be knowing about the layer 2 loops, which sometimes is a nightmare for a network engineer, right? And understanding of these loops or understanding of this protocol which avoid this loop is really crucial whenever you are trying to learn networking concepts, right? So having said that, in this video we are going to discuss how to avoid loops in layer 2 network, and also we are going to understand some concepts regarding virtual LANs, right? Because the protocol, which is spanning tree protocol that is used to avoid this loop, works per VLAN basis. Okay, so we are going to introduce the concept of virtual LANs also, or the VLANs also. Okay, so let's move towards our first board. So first of all, first thing first, we need to understand what exactly this layer 2 loop is. Okay, so here consider this topology where we have three switches: switch 1, switch 2, which is right here, switch 3 here, and then basically I have connected two laptops or two hosts, host A here and host B here. Because we are talking mainly about the layer 2, so I have written only the MAC addresses here. MAC address of host A is A colon A colon A. MAC address of host B is B colon B colon B, right? Very simple topology. We have only three switches, and I have mentioned the interface names also, right? Do not confuse with these names. It could be any name, right? But for the simplicity, for the clarity, I have mentioned the names also. One more thing, guys, believe me, the knowledge of my previous videos, video number 1, 2, 3, whatever we have in this series till now, is really, really important if you want to understand the concept of avoiding loop here, right? And I request you to go through all those three videos first and then look toward this video, because we are again going to discuss about address resolution protocol here, right? And if you have firm understanding of ARP or address resolution protocol from my past videos, it is going to help you here also. Let's try to understand what exactly the loop is. So suppose this guy here, host A, wants to communicate to host B here, right? And it initiates a ping towards host B. So what exactly happens, guys? From our last videos, we know that because we are going to communicate into the same network, so suppose and this host is part of the same network, and I have initiated a ping from host A. The problem is I'm not going to have the MAC address of host B, and that is why I send a ARP, address resolution packet here, right? Which is received by 0/1 port of this switch 1. And what exactly this switch will do? It will forward this ARP packet or frame on all of the interfaces except from the one on which it got received, right? It is not going to send it over here. Very simple concept, right? So as you know, this ARP is a broadcast packet, right? And switch sends it across its all ports except on the port where it was received. I'm repeating this thing, right? and I believe you all know this. Now, this packet, this R packet, I am denoting it this rectangle, it is going to reach to 0/1 port of the switch 3. And again, the same R packet is going to receive at port 0/3 of the switch 2, right? What exactly happens now? This switch 3, because again, this packet is a broadcast packet, it is going to advertise it exactly onto this interface. And when it's going to send over this interface, it is going to receive on 0/2 interface of the switch 2. What exactly the switch 2 is going to do? Because again, it's a broadcast packet, it is forwarding it towards the 0/1 interface and again the 0/3 interface. And the problem is that we are forming a loop here, right? The packet, our packet from here, it was going to switch 3, it was going to switch 2, and then it is coming back again to switch 1. And the problem just do not stop here, right? What exactly happened? When this switch 1 again receives this R broadcast, it is not stopping here. It is again broadcasting this packet on the 0/2 interface, and again switch 3 is going to repeat this. It means that we have a loop in our layer 2 network. And if there is a loop, then basically every switch, every router these devices are programmed to work as fast as possible to forward all these frames. And as soon as this switch 3 receives the ARP, it is going to send it across its 0/2 interface. And again, this switch 2 is doing the same, switch 1 is doing the same. So you can understand every switch gets busy, right, in forwarding this ARP frame. And sometimes we see almost 100% CPU if we do not stop this loop, right? Because every switch is busy in processing all these R frames and sending these R frames to everybody, right? So this is the problem. So if every switch reaches to 100% CPU, then it is not going to do any other work, right? And that is where your whole layer 2 network goes down. Believe me, one single R packet, if it is making a loop in your layer 2 environment, it is going to be disaster for your layer 2 network, right? If I say layer 2 network, it simply means that it is the network of your switches. It is the network towards your LAN side, right? So this is the problem, guys. This is the problem of looping. Means the R packet is going and coming back again to the same switch, and this switch is again not stopping right here. It is again forwarding, and this is basically we have infinite loop here, right? So the problem is the loop. The second thing is the second problem which is there is the MAC address flap, right? So as you know, that switch builds its CAM table on the basis of whatever the source MAC of the incoming packet, right? So basically it creates these two columns. So 0/1 interface, basically attached, there is a host attached which is A::A::A. And how this switch knows about it? Because of this R packet, right? This R packet contains the source MAC address of this host A. And that is why when it is received on 0/1 interface of this switch, switch 1 creates its CAM table where it mentioned that 0/1 interface, this address is located, or you can say A::A::A machine or the laptop is located over 0/1 interface, right? But my problem is, it is as there is a loop in the system, this frame or this address resolution protocol message is going over here, it is coming over here, and again coming over here over this line. It means that the switch will learn the same MAC address A::A::A via 0/3 interface exactly here. So there is no way, right? Switch can decide that whether it is attached to 0/1 or 0/3. So what exactly it does? Because now the same MAC address is attached to two interfaces, which is the cause of a problem here, right? This is ambiguity. So what switch is going to do, it is going to just delete this entry and put this entry into the CAM table, which is, by the way, guys, a wrong entry. right? Because A:(A) is not connected over this 0/3 interface. It is connected over 0/1 interface. But because of this looping, we are learning this over 0/3 interface, and we are having a false scam table. So the problem is even bigger. The first problem, obviously, CPU, high CPU, 100% CPU on all of your switches, right? And if this is 100% CPU, your switches are not going to do any other activity. Then the second problem, if they do some other activity, then there is a problem of MAC address flapping, right? So big problem, guys. Now we need to think that how we can avoid this layer 2 loop, or whatever the loop we have discussed, how we can prevent this MAC address flapping problem. Okay, interesting. This is good. So let's move towards our next board, where we are going to explain the concept of VLAN first, right? To understand basically how we are going to avoid this loop. So the concept of VLAN, guys, is very, very simple, right? Suppose I have a switch here. This is my switch, and there are 4 hosts connected to it. Host A, host B, host C, and host T. Very simple, right? What exactly happens? Right? By default, when this host wants to communicate to host D, say when host A wants to communicate to host D, what exactly it is going to do? It is initiating a ping packet, but it doesn't know the MAC address, and that is why the first packet goes out from this host is the address resolution protocol, which exactly says that what is the MAC address of this IP address. For example, this D has IP address of say 2:2:2:2, and I have the IP address of 1:1:1. This D has the MAC address of say D:(D:)D. So the question is simple through the ARP message. What is the MAC address of IP address 2:2:2:2? This is nothing but the R, right? Simple. Now, this is the broadcast message, and that is why it is forwarding across all the ports. So see the problem here. Along with the D, the packet is forwarded towards B and C, right? And every R packet which is received by any host, right? It is the host's responsibility to process that packet to see whether it is for him or not, right? So although this packet was for D, but your host B, this one and this one, is also processing that packet. And the reason is because every R packet needs to be processed by each host, right? Because that is for the broadcast address. And when you open this R packet, these hosts come to know that whether this R packet belongs to them or not, right? It means that you need to process it, right? And that is why D came to know that yes, this packet belongs to me. But this is the problem, guys. Right now, I am just talking about 4 hosts in the system. What exactly if we have more than 200 hosts present in the system, right? It means that the packet was for, although the packet was a broadcast packet, but it has to be processed by remaining 199 hosts in the system, right? Which is a problem, right? You are wasting your CPU cycle. And believe me, if this domain, if this number of hosts becomes sometimes maybe 512, the problem is even worse. And suppose at the same time, more than one host initiate this ping and eventually the ARP, it is going to be a problem for everybody, right? So how we can resolve this problem, right? I am sending an R packet and it is received via many other hosts. So can we do something so that my R packet remains in a particular region? And that is exactly where the concept of VLAN comes into picture, right? If I want to divide this network into 2 parts, right? This is part number 1 and this is part number 2 of the property of this part number 1 and part number 2 of the network is, if I initiate a ping or eventually an ARP message from host A, it is going to be received by only those hosts that is part of this network, right? So as I mentioned, this A and B are part of the same network which I have divided, right? Previously, it was a complete network. I have divided into 2 parts in terms of switch port, the switch port 1 and switch port this 02 belongs to this network, and switch port 03 and switch port 04 belongs to this network. It means that whenever I initiate an ARP, whenever this host sends an ARP message, right? It is going to be there in this network only. It means that only host B will be able to receive it, and not C and not D, right? So we have divided, we have segmented this network into two parts. If you consider the host C here, if I send say R packet from host C, it is not going to be forwarded in network 1. It is going to be forwarded in all the hosts who are part of this network 2. Suppose if I have another host here, it is going to be forwarded there, but not to A and not to B, right? So this is interesting, guys, right? I think this makes sense, right? So if I have more hosts in a particular network, it means that there is more address resolution protocol traffic, and then basically every host needs to process this packet, right? And that is why we segment our network into multiple parts. And that is why I have mentioned that we can segment switch ports. So if you can see, switch port 0/1 and 0/2 belong to network 1, and switch port 0/3 and 0/4 belongs to network 2, right? And these network 1 and network 2 are just nothing. These are your VLAN. You can say this is my VLAN 1 and you can say this is my VLAN 2, right? So if I may define this VLAN definition, then just try to understand, just try to listen this, right? A VLAN is a group of hosts in which if a particular host sends an ARP message, it is going to be received by all other hosts of that group, right? So I have created this group or this network. If I send an ARP request from C, it is going to be received by D only, right? It means that it is a set of hosts which is creating this VLAN. Okay, if I send an ARP from a particular host of this group, it is going to be received by all other hosts in that group, right? So this way, basically a switch can be divided into multiple VLANs. And why we are dividing it? Because we do not want large broadcast domain. And what is the meaning of a broadcast domain? The meaning of a broadcast domain is if I send a ARP packet from here to host A, and it is going to be received by many hosts, then all those many hosts are part of that broadcast domain. It is as simple as that, right? So right now, if I have segmented this into two parts, network 1 or VLAN 1 is one broadcast domain. VLAN 2 is another broadcast domain, right? So by default, so you must be wondering that if there is any VLAN at the first place in the switch, and exactly there is a VLAN. So we call that VLAN as VLAN number 1, which is already there. So if I give you a clear picture, then basically this VLAN 1 and the CAM table of any switch. So if the switch builds a CAM table, then actually instead of 2 columns, it is going to have 3 columns. One is VLAN, the other one is your interface, and the next one is your MAC address. So it is going to say that host C, which is having C:, C: MAC address, is connected to 0/3, but at which VLAN? It is going to be VLAN number 2. So by default, there is a VLAN 1, guys, right? So now let's try to visualize this concept of VLAN. And I believe you understand this diagram pretty easily. Right now, if you can see, we have VLAN 1, which is by default there in the switch. And in that VLAN, we have host A and we have host B, right? Similarly, we can create another VLAN which composed of these two interfaces in the switch, and then basically we have host C and host D part of this VLAN, right? So this is interesting, guys. So we can have multiple VLANs, we can have many VLANs on a switch. And if I say I have a particular VLAN number 10 on a switch, then basically we need to define what are the interfaces part of that VLAN so that I can define endpoints or the host connected to it are part of that VLAN. Okay, so VLAN 10 is going to have these two interfaces 0/3 and 0/4. By default, VLAN 1 is in which every port of the switch is there, right? So here, but in this case, 0/1 and 0/2 is part of my VLAN number 1, right? Believe me, guys, the concept is really important to understand. Okay. VLAN is just nothing, but you are dividing your switch ports into multiple parts, into multiple networks, right? You can resolve the problem of broadcast. And by the way, guys, this broadcast, these R packets are creating problem at the first place. You remember in the last diagram what we discussed, we have three switches, right? And the R packet was going here, coming here, and then coming back here. And it is creating a loop, which is making these switches to be at 100% CPU level. And there was a problem of MAC address flapping. So now let's discuss how we can avoid the looping problem of the layer 2 network, right? Again, the same diagram, right? Now, the idea is that you can physically see that basically there is a loop in this network, right? This is the loop, this traffic, then basically if you can see this and this. So this is a closed loop and our messages are flowing over it and they were creating a problem. So what is the best solution, if I may ask, what is the best solution for this loop to avoid? And the best solution to avoid this loop is very simple, right? And what is the best solution is if you can just remove this link, right? If you can remove this link, then basically there is no problem at all. There is no physical loop and there is no logical loop also. Very simple, right? But as you can see that in this simple net, you can figure out the loop and you can just shut down that link. But it should not be your responsibility. There must be somebody, there must be some protocol who is doing on your behalf all these things, right? And believe me, there is a protocol called spanning tree protocol, which is going to do the same thing, the exact same thing, right? It is going to avoid loop from your network, right? So idea here is whatever the link which is creating loop, we want to block it, right? But the problem is, suppose if I manually shut this link down, right? And I am happy that my network doesn't have any loop. What is the problem here? The problem is, suppose if this link goes also down, right? Somebody has just plugged out the cable, then basically this device is completely out from my network, right? And irrespective of the fact that I had one link, right? So the simpler solution is if somebody has plugged out this cable, then you go and just make this link enable, right? But too much of manual work, right? And that is where this protocol comes into picture, which is spanning tree protocol, whose responsibility is to avoid these loops from the layer 2 network, right? And how exactly it is going to do this, which we are seeing in a moment, right? So I think you understand the problem. You understand the problem. There is a loop and we want to avoid it, right? So there may be different methods. There may be different algorithms to avoid this loop, right? But on Cisco switches, you can see that we run spanning tree protocol, right? To resolve this problem. And how it works, let's see that in action. So the first thing first, what you need to do, you need to find a position or a place where you can begin at least, right? And that place is exactly the root bridge, right? Or the root switch, you can say. So this switch tree, suppose, is the root bridge. But the question is, how am I going to select the root bridge, right? Because there are three switches. How I am going to select this root bridge? And the answer is really simple. Whoever is having the lowest MAC address, okay, is going to be selected as root bridge. So suppose the switch tree has the MAC address of say 0:0:0. And believe me guys, this 0:0:0 is the lesser number than this also. So it is going to be root bridge. But how this election is going to happen, right? In real network. So basically, when you connect these switches, switch 1, switch 2, switch 3, they start talking, right? And how they start talking is they start sending some messages to each other, right? And we call those messages as bridge protocol data unit or BPDUs. And what exactly those BPDUs are? Those BPDUs contain, right, information about the MAC address, right? So to begin with, every guy, every switch says I am the root, right? So switch 3 is going to say I am the root, switch 1 is going to say I am the root, and switch 2 is also going to say I am the root. But now it is the responsibility of spanning tree protocol to decide who is the root. And what we are trying to do, guys, here is we are just trying to find out a place from where we can begin. Where we can begin for what? Where we can begin for a free topology, right? So this guy says I am the root, switch 3, and it says that I am having this MAC address, right? And when it receives, the switch 1 receives this, switch 1 knows, oh, there is another guy in the network who is having MAC address less than me. So I should stop myself advertising as a root, right? Whenever I send this the BPDU message toward the switch 2, I am going to say, see, I am not the root here, and the root MAC address, which I believe is the 0:0:0, and this guy also received the same thing, right? Previously the switch 2 was saying I am the root, but now when it receives the packet with 0:0:0 MAC address, it will see that basically I am not the root. So similarly, when this message flow across your topology, now every switch knows, right, who is the root bridge. Okay, the root bridge in this topology is going to be switch 3 because this is having the least MAC address, right? So we are done with the first step of this algorithm, how basically we are coming across a loop-free topology, which is the first step was root bridge election. We are done. That root bridge is going to be switch 3 because this is the one who is possessing the less or the smaller MAC address. Very simple. Now, the question arises, guys. The question here is how you are going to make sure that we always choose a link which is best for us, right? For example, suppose I have these three houses. Maybe this is house number 1, this is house number 2, and this is house number 3. They are connecting like this, right? And from 1, I want to make sure to reach to house number 2 here with the shortest distance or with the shortest path. Believe me, guys, this road can be of 5 kilometers and this road can be of 2 kilometers and 2 kilometers, right? So at the first glance means you must be saying that this path is shorter, but no. If this metric of or basically if the length between these two houses is more, if the distance between these two houses is more, then basically this is not the optimal path for us, right? The optimal path is going to be this and this, right? So what we are doing here is we are selecting, we just want to eliminate one route, one link to eliminate our loop. And to do that, we just want to make sure that we should not trim out the link which is basically having least cost, right? So presume just for now presume that we are having here the distance between this guy and this guy is 10. This guy and this guy is also 10, suppose, and here the distance maybe say between this is 5, right? And the distance, whatever the unit I am mentioning here we call it as a cost. The lower the cost, the better the path, right? So suppose if I have a path here with the only 3, right? What is the best path from switch 3 to switch 1? The best path is going to be like this instead of a direct path, right? Because we have less cost associated with it, right? So the cost is a major factor here when we decide our links. So the second point is basically we need to find a root port. And what is the meaning of the root port? The meaning of the root port is find a port which is closest to the root bridge, right? Find a port that is closest to the root bridge. So here, if you can see, we have switch 1 here, right? And basically, by the way, guys, whenever we select a root bridge, we need to calculate the root port on all those switches which are not root, right? So suppose we are at switch 1, right? So we will be receiving the BPDU from switch 3 in this direction and this direction. As I mentioned previously, this BPDU contain the MAC address information, and also these BPDUs are going to contain this cost information also. The cost is here say 10, here is say 10, and the cost here say 5, right? And the problem here is that this guy is going to receive the cost with 10, and on here it is going to receive with 10 plus 5, the BPDU to reach switch 3, right? And of course, the shortest path is going to be this, and this port will become the root port, right? So if you consider on switch 1, there are only two ways to reach switch 3. One is via this way, one is via this way. But the cost of this way is really high. It is 15, and the cost to reach from here, it is simple. It is 10, right? That is why we are going to say 0/2 port is the port which is most closest to the root bridge. And that is why we say this is my root port. Very simple. Similarly, here 0/2 port is going to become the root port. Very simple. But now the question arises, which one is the root port here, right? And believe me guys, you need to find the root port. Root port is going to be only one per switch, and we have identified, right? So my question is that which is the root port here was wrong. So simply we need to find one root port on a switch. Okay. Now the third step of this algorithm is define the designated port. Designated port means the port which is the best port on a particular segment. And what is the meaning of segment? So in this layer 2 network, we are having three segments. One segment is this one, the second segment is this one, and the third segment is this one, right? So very simple. If a port is not a root port, then it is going to be the designated port. So in this link, what is the designated port? This port is going to be the designated port because only two ports are there. One is designated port because this is the root port, right? Similarly, on 0/1, this is going to be the designated port, right? Now, my question is how we can identify the designated port here, right? Because I have already find the root port on these two switches. And the idea is simple. I need to check which port is better, which port is sending the best BPDU, right? And the problem is this guy is sending the cost to reach switch 2 is 10, and this guy is again sending the cost to reach to switch 3 is 10. And of course, when they forward it, they add 5 over it, right? So in terms of the cost, switch 1 is receiving that switch 3 is 15 cost away from me. Switch 2 is saying the switch 3 is 15 cost away from me over this link. So there is a tiebreaker here, right? We are not sure who is sending the best BPDU. And that is why we see that what is lower MAC address. So lower MAC address means it is going to be the best BPDU sender, right? So basically, if you can see here, the MAC address is going to be the MAC address of this, so it says A:(A:)A, right? Not this host, and this may be the B:(B:)B. Then obviously this MAC address is going to be small, and we are sending BPDU over it. It means that this port is the best port over this interface or over this segment, and we choose this port as the designated port, right? So here is the problem. This port is nothing. It is not a root port. It is not a designated port. So the simple thing is, if the port is not a root port, not a designated port, it means that you need to block it, and it comes under the blocking category. If you block this link, then means this link is totally blocked by STP, right? Very simple. So I am cleaning this diagram, guys, because it is getting too much cluttery. Okay, so over the entire process, means after selecting the root bridge, root port, we came to know that this port is root port, this port is root port, right? This was my designated port. And why this port was root port? Because it is the closest to the root. And this port become designated port. Why? Because it is sending the best BPDU. How best? Because in terms of cost, everything is fine. This guy was receiving 15 cost, this guy was receiving 15 cost. So the second parameter is basically the MAC address, who is having the less MAC address or the lower MAC address, and we are having switch 1 as the lower MAC address, and that is why basically I'm sending the bridge BPDU with the lower MAC address, and that is why exactly here, exactly this port is going to be my designated port, and this port has become the block port, because if a port is not designated port, not root port, it is going to be block port. Okay, so we just eliminate this port, right? A spanning tree, just eliminate this port. Okay, so having said that, guys, this port is up, this port is up, and our main intention, our main motive have been achieved, right? That this port is down now, which is creating the loop, and we have disabled the port or the link, which is basically not required, right? But now, what happens? Suppose if this link also goes down, right? Then it is the responsibility of STP or the spanning tree protocol again to make this link up, because otherwise this switch is going to be standalone, right? Nobody is going to reach to it because both the ports are going down. So it is the responsibility of this STP. If this goes down, then it will make this block port again the root port, because now that there is no root port on the switch, there is no way the switch can reach. So whatever the port it has, it is going to be the root port, right? And this is as simple as this, right? How you are going to make sure, how STP going to make sure that which link to remove, and once basically it is required to be up, it makes it up. Very simple process, and this is what exactly I wanted to explain you in this video, that how you are going to avoid layer 2 loop, right? So the intention of this question can be anything, right? The intention could be whether you understand the layer 2 loops, whether you understand spanning tree protocol, whether you understand VLANs. Now you can say that why at the first place I explain you VLANs, and the reason is this spanning tree protocol work per VLAN. So if the switch is having two VLANs, right? VLAN number 10, VLAN number 20, then this spanning tree protocol is going to be running in this VLAN and in this VLAN also, because this VLAN, the concept of VLAN, or you can say the VLAN is just nothing. VLAN is the group of switch ports, right? And here we are seeing the switch ports are connecting, and we are running protocol STP over those switch ports only, right? By making them designated port or root port or whatnot, right? So if there are two VLANs, then basically we are running two spanning tree protocol or two spanning tree instances in those two VLANs, right? So it is always important to know VLANs. It is always important to know how you are going to avoid layer 2 loops in your layer 2 environment. Okay, so having said that, thank you so much, guys, for watching this video, and we will meet next for our fifth question of this series. We will be meeting soon for our fifth question of this series. Okay, so having said that, bye for now. Enjoy your day.